Alright, in this section here we're going to be talking about multiplying and dividing rational expressions. So of course we get started with an example. You know, some of these steps we've already done, but that just happens to be what this section is, multiplying and dividing, even though it's going to seem like we've already done some of the same stuff. Okay, let's start with starting with 5x times y squared, and that's going to be all over 3a times, now this is the multiplication, I'm going to use a dot for multiplication, 2x cubed y, and that's going to be over 7a to the fourth and b. And I think up to this point I haven't mixed variables like a and x together, a and y or a, b and y or whatever. So alright, so we want to simplify this down is what we want to do here. And so what I'm going to do is, we got 5, 2, 3, 7. Okay, so this multiplication here means we can just multiply each one of these terms together. Now that doesn't really make any sense. Okay, I don't know, just watch what I do here. So 5 times 2 is 10, and 3 times 7 is 21. And of course we can't reduce this fraction down. I'm going to just go ahead and put multiplication here. Now we have an x and an x cubed. I'm just going to put them side by side for right now, trying not to skip any steps. And we have a y squared times a y, and down here in the denominator we have an a times an a to the fourth times b. Okay, we have, now this is to the first power, and we've done this before in the previous sections. We add exponents, right? Our base is the same. We add these exponents, we end up with x to the fourth times, we have a 1 here, or 2 here, 1 here, so this becomes y to the third. It's all over, right? A to the fifth, so it's going to seem like we've been repeating. We've already done this kind of stuff, but that's okay. We're going to do it again. I don't know, I could have wrote it like this, 10x to the fourth, y to the third, and that's all over 21, a to the fifth, and b. And just to say something here, it doesn't matter what order we really kind of write this stuff in, but usually we write we'll write the variable with the largest exponent first, and then kind of in descending order. Really, that's the way that really works out. Alright, well let's this has been reduced now all the way down, so let's work on another one. Alright, let's see, we got 4s, use some different variables here, st over 2m times 9m cubed over n, and then, or over 6t, I meant to say, 6t to the 8th. Alright, so we want to reduce this down. Now let's look at our numbers here. We got 4 times 9, I'm going to kind of group all these together, and then we have 2 times 6, s to the 4th, so there's really nothing we can group together there. T m cubed over n, and that's over m times t to the 8th. Okay, let's look at this piece here. What I'm going to do now is I'm going to factor this stuff here and show you how to cancel this out to reduce it all the way down. Alright, so let's break, yeah, I'm just going to do it this way here. So 4 can be broken up as 2 times 2, and 9 can be broken up as 3 times 3. And we're going to rewrite that 2 there, and this 6 can be broken up as 2 times 3. So these have been factored into a product of primes. Now I can cancel some things out. So it's just a whole lot easier seeing this, right? So these 2's here cancel out. We have a 2 in the top, 2 in the bottom. Those 2's there can cancel out. 2 over 2 is 1, right? And we can cancel out these 3's, so we're just left with the 3 now. Alright, and the rest of this stuff, let's see. We just have an S, a T, we've got 8 T's in the denominator, and M to the third, we got 1 M here. Okay, so this would be S to the fourth times. Now I'm going to cancel this T out, and then we'll just be left with 7 of them down here in the denominator. Right, and I'm going to cancel out this M, and then we'll just be left with 2 of the M's up here. Alright, so hopefully you didn't get too confused on that. And that's going to be M squared times N over, we cancel that M out, and we're just left with T to the 7th in the denominator. Now of course we're going to write it like this, our final answer. We'll bring that 3 up. S to the fourth times M squared times N over T to the 7th. So that's what all that reduced down to. Don't equal sign because this is still equal to our original expression up here. Alright. Alright, let's see what we got here for a new problem. We've got 16 x y squared over 12x y squared times 3x squared y over 4y to the 6th. Now, before we even get started here, we know that we have a y squared and a y squared, so this is going to cancel out, and so are our x's here. Actually, that should have been an x cubed there. Sorry about that. Alright, let's just go ahead and instead of multiplying this stuff together, let's go ahead and see what we can reduce first and then multiply it together. So we've got 16 here. That can be written as 4 times 4, and 12, it can be written as 4 times 3. Right? This x is going to cancel. We'll be left with 2 in the denominator, and of course those guys will cancel out altogether, so we just be left with 1 over x squared. Alright, times, let's look at this, 3x squared. We have a y, 6 y's, so that y is going to cancel out. Be left with 4y to the 5th. Alright, so we'll be able to cancel out the 4's. Those will stay the same. And you know what? We can also do this. We have a 3 down here, a 3 up here. Wow. A 4 down here, and down, or up here down there. Yep. Well, as you can see here, these x squareds will cancel out, and we'll be just left with 1 over y to the 5th. Well, that just kind of magically happened really fast, it seems like. But anyway, so just real quick here, I had to chop the video in two. That's the reason it's like it is. But right, we had an x squared, and of course those are going to cancel out, and we're just left with 1 over y to the fifth. So it's kind of amazing, you know, that all this craziness up here can reduce down to 1 over y to the fifth. Alright, so let's look at some more. Actually, I think in this next one here, we're going to actually talk about dividing rational numbers. Or rational expressions, I should say. But we'll start with rational numbers, is what we're going to start with. So let's erase the whiteboard. Boy, that's nice. I bet some teachers out there would like to be able to just click a button and erase the whiteboard like that. Let's start with a rational number. Okay, so let's say that I had 1/5. And 1/5 was divided by 1/7. But we want to rewrite this, or let's say we want to work this out. Okay, now this 1/5 over 1/7, how many 1/7s go into 1/5? We could actually rewrite that as 1/5 divided by 1/7. Now, I don't know this for a fact, but you see this line right here? This is like the division bar, and that dot represents that number, and this dot represents this number. I don't know, sounds good. This is the form that we're going to write we're going to start off with this form right here. But if we wanted to actually solve this, we would say, okay, we want to get a 1, just a 1 down here in the denominator. And I'm going to do that by multiplying by 7 over 1 in the denominator, but what I do in the denominator, I've got to also do up here in the numerator. So as you can see, these guys will cancel out, and we'll just end up with 1 down here in the denominator. And if there's just a 1 down here, we don't have to write it. Right? But I am going to write a 7 over 1. So just in short, so we don't have to do this every time, when you see the division sign, just take this number here and you flip it. You know, it's just really that simple. You just flip whatever this is. So 7 over 1. Then of course we multiply 1 times 7, 5 times 1. Right, so this becomes 7/5. Alright, so that reduces down to 7/5. Okay, good enough. Let's work some stuff with some variables in it now. Alright, let's try, for example, 15 over 3. And we'll say A, B, C over B cubed, C cubed, divided by 10 A C cubed, and that's all over 4b c to the fifth. So what we can do first is we can reduce this down and then go from there. How's that? Let's do that, right? So 3 goes into 15 5 times. We'll rewrite the a because we don't have any other a's in the denominator. B, we got 1b in the denominator, we got 3 in the top, so we're going to cancel this one out, and also the c. Okay, and so we canceled 1 out of the top, we need to cancel 1 out of the bottom. That's going to leave us with 2 b's and 2 c's divided by, do the same thing here. Let's see, 2 goes into 10 5 times. A, we'll rewrite that, and we're going to cancel 3 c's out of the top, and that'll leave us with 2 c's in the bottom. And of course 2 goes into 4 2 times. B we rewrite, and C is squared. So now we're going to go 5a, rewriting b squared, c squared, and I'm going to flip this now. Time to flip. Alright, what we're going to do is we're going to flip this. So this becomes 2b c squared over 5a. And as you can see here, that we're going to be able to cancel some stuff out, like the 5's and the a's. We've got a b in the numerator up here, a b squared. Look, c squareds are going to cancel completely out too. So let me just rewrite what we've got, so we won't get too confused. You know what? I'll just write it right here. So we have 2 b, what are we left with? 2b over b squared, I guess. That's what it looks like. And of course that can reduce down to 2 over b. Wow. Amazing. Hopefully I didn't make any little errors there. So all this reduces down to 2 over b. Great. Time to look at another one. Alright. Let's see, what do we got in store? I think I need to mention this real quick. If I had a 4x times, let's say for example, 3x over 2y, okay? So if I had 4x times 3x over 3y, this would just be, you would multiply 4x times 3x, so that would end up being 12x squared over 2y, but of course this would reduce down. 2 goes into 12 6 times. So 6x squared over y. When we were multiplying, I'm not sure I mentioned that, but anyway, so you just multiply this by the numerator, not by the numerator and denominator. You multiply 4x just by the numerator. Alright. Okay, so something a little bit more difficult. How about 2x plus 2 over 5x minus 15 divided by now, you know what? It's not going to be divided by. Let's get rid of that. I'm going to erase that. We're going to multiply because we haven't done one of these yet. X minus 3 over xy plus y. And the reason I'm going so slow is because I'm giving you a chance to hopefully write this stuff down. So we want to simplify this. I'm going to factor out a 2. We'll be left with x plus 2 over, and I'm going to factor out a 5 out of the bottom, and so we'll be left with x minus 3. This is times, so there's nothing we can do there, but we can factor out a y out of this part, and so be left with x plus 1. So now what we want to do is do some canceling. So I can cancel this x minus 3's out, and looks like that's about it. Alright, so we're going to be left with 2 times x plus 5 over 5 times, oops, don't forget the y, about forgot it. Let's throw the y in about right here, and then this would be x plus 1 right there. Alright, so we're done with that. Alright, so we are trying to simplify some rational expressions. let's look at this one here. We got 5m plus n. That's going to be over. Man, that line was terrible. Let's see, 2y minus 2x. 2y minus 2x. Actually, minus 2xy. How's that? And we'll multiply that by 6x minus 6. And that's going to be over 20m plus 4n. Alright, so we want to simplify this thing down. Well, there's nothing we can do here, so I'm going to end up rewriting that. So that's just going to be 5m plus n. However, this one here we can factor out a 2 and a y. Okay, so factoring out a 2 and a y, it's going to left with 1 minus, just a 1 minus an x times. Now up here we can factor out a 6. That'll be left with x minus 1 over, and we can factor out a 4 out of that piece there, so that's going to give us a 5m plus n. Now we're going to be able to cancel some things out here. We have a 5m plus n up here, and we have one down here. This 2 can go into 6. Let's see, we have a 1 minus x and we have an x minus 1. Now there's going to be a trick that takes place here. We're going to factor out a negative out of, let's just factor it out of the top here. So I think what I'm going to do here is rewrite some stuff that we've got actually. I'm just going to rewrite this. 6x minus 1 over, we have 2 times 4 is 8, y, and then we have a 1 minus x. Alright, 2 goes into 6 3 times, and 2 goes into 8 4 times. And I'm going to rewrite this y. Now I told you I was going to factor a negative out of the top here, so we're going to do that. And that's going to be left with a negative x plus 1, and of course that's all over 1 minus x. Now I can rewrite this. I'm going to put this negative out front, bring the negative out front. We have 3 1 minus x over 4y 1 minus x. So as you can see now that the 1 minus x's will cancel out, and we are finally going to be left with a negative 3 over 4y. So hopefully I didn't make any mistakes on that. Alright, so all that is equal to, what did I say it was equal to? Alright, negative 3 over 4y. Alright, this next one here ought to be fun. (3x squared) plus x minus 4, and that's going to be over, what will that be over? How about x plus 5 divided by 6x squared plus 11x plus 4. And we'll put that in parentheses. Alright, so we want to simplify this thing down. Question is we need to factor probably this, but you know what? First thing I'm going to do, I'm going to rewrite this as 3x squared plus x minus 4 over x plus 5. Now, this is going to be rewritten as 1 over 6x squared plus 11x plus 4. Alright, because this is assumed here to be over 1. Okay, so remember we flip it, so that'd make that 1 over. Alright, now it's time to factor some stuff, hopefully cancel some terms out. This up here can be factored as, let's see, I don't actually have this worked out, so this ought to be interesting. So it's got to be a 3 and a 1 here as coefficients in front of x. We got no other choice. And let's see, a 2 and a 2, so that would be 6. And no, that's not going to work. What did I say? Yeah, 2. It's going to have to be a 4 and a 1. A 4 and a 1. Yeah, I'm going to put a 4 here and a 1 here. This is a plus, so we're going to make that a plus and that a minus. So 4 times negative 1 is negative 4. Alright, so 3 times negative 1 is negative 3, and then 3x plus 4x will give us 1x. Okay, good. And then that's going to be over x plus 5 times 1 over. Now we got to factor this. Now I'm going to take it, there's probably a 3x plus 4 down here hiding out, or an x minus 1. So let's factor this into 3x and 2x. How's that? And I'm betting there's probably a 4 down here. We need a positive 4, so probably a 4 here and a 1 here. 4 times 1 is 4. We need an 11. Let's see. That'd be 3x and 8x. And 3 and 8 is 11. Yes, good. So that's going to be a plus, obviously, and a plus. So now we can cancel some things out. Actually, you know, I should state this. I'm not sure I did in any of those other problems. Because this is multiplication here, we can join all this together as one single fraction. For example, we'd have 3x plus 4 times x minus 1 times 1, so we're not going to write anything else on top, and then this becomes x plus 5 times 3x plus 4 times 2x plus 1. Now we're going to go ahead, cancel, and rewrite. So we're going to be able to cancel the 3x plus 4's out, and looks like that's about it. So we end up with an x minus 1 in the numerator and an x plus 5 times a 2x plus 1. Now, I don't think I've done this in any of the other problems, but you know, we'll just leave it like this. But if you want, you can multiply this stuff all back together if you want. Multiply it out, and anyway. But I'm going to leave it like it is right here. Alright?